Welcome. Yeah, as Trudy mentioned, we've been here for a few months. We're running this company for about 3 years. In this space, we'll walk around and I'll show you everything, but we do a range of different things. So in this space, we actually build plastic recycling machines for communities, school groups like yourselves. Everything's made here in Richmond, and we're building, I think, 10 or so injection molding machines. Those are the skeletons of this machine here, which is our plastic injection molding machine. So does anyone know about precious plastic as a community? Have you heard of precious plastic before? Never? Okay. Precious plastic was developed in the Netherlands by a Dutch designer called Dave Huckens. As part of his university projects, he designed a bunch of small-scale plastic recycling machines. And at the end of the year, he gave the plans away for free, the blueprints, the build material, so that people like ourselves could build machines and have an impact in our own country. The reason that was so important was because traditionally recycling was only done by those who could afford hundreds of thousands of dollars or $1 million equipment. But he saw that there was a gap, especially in countries in Southeast Asia or developing countries where recycling wasn't happening. He was able to send the plans over and they were able to start having their own impact. If anyone's ever been overseas to Bali or to Thailand, you'll see there's rubbish all over the beaches. And the idea is for those communities to be empowered to do something about the recycling or the mess, not just rely on governments and whatnot to do something. So a few years ago, we had another company and we needed to develop our own product. We looked locally and internationally for a manufacturer. But we had to make sure that the manufacturing method was responsible. So whether it be from a labour perspective or from a material perspective, we wanted to make sure that we could produce something that aligned to our values. We looked at making our product out of wood, ceramic, glass, and we finally found plastic. We thought, well, plastic's not good, until we realised recycled plastic is probably okay. Our industrial designer found the precious plastic community, and he said, well, we can build these machines, that shouldn't be a problem. And we can get a mould made, and ideally it should be cheaper than getting a prototype done at a local manufacturer or sending it overseas. So we did, we built an injection moulding machine and a plastic shredder, and to this day those plans are still available for free. If you go to preciousplastic.com, you can download and look what those plans are, and those machines. And so we started building the machine for ourselves. We ordered a mould. We found that it wasn't cost effective to buy a mould here in Australia. We actually found one cheaper in Germany, which is sort of unbelievable to have to travel all the way over to Germany to find something cheaper than here. But we had the mould made, and then we realised, well, what we're about to do is small scale recycling. Why don't we open up our doors? Why don't we join the community and then produce products, or at least educate our community on what can be done? So we opened our doors and we started manufacturing for other people. And what we found was people were very excited by the concept of local and small scale manufacturing. Because I guess to date you'd think, I need to go make something, I've got to go to China, I've got to go to Europe, and I'm going to buy millions of items. Whereas we were here, we could say we can make you a few hundred at a time. And so that was really exciting. Cut to later, we realised that there was probably a demand for the machinery. And we realised there were some struggles building these machines because the parts that they listed on the bill of material would often reference European suppliers, or go to the tip, go to the dump and find an old motor or whatnot. And when we realised that there was a bit of a demand, we couldn't just go to the tip to buy our supplies or to get our supplies. We had to buy reputable products that are going to last. We could have put a warranty on it. But then in consultation with schools, we realised that the original precious plastic machines were probably not safe, not easy to use. Only that you would, for example, the injection moulding machine had a long lever, and to pull the lever you'd probably have 3 students hanging off. The shredder didn't have any guarding, so you could easily put your hands down there and have a big legal problem. So we redeveloped and redesigned what we saw as the precious plastic machines into what we are now calling the Zephyr Brothers range. So these are machines that we make here and we sell to schools right around Australia. We even ship them to Europe. We've got a few of our machines on yachts and boats that are travelling around the world, who are educating coastal and rural communities about recycling. And so this one, is our injection molding machine. We won't do a demo on this day, we'll do a demo on our other machines over there. But this is the machine that we actually use to produce a range for Country Road. And in doing that, what it means is people can be inspired by doing it yourself in a small scale. We don't have to be large organisations to be selling to places like Country Road. So this facility, you'll see, obviously we've split up into cells. So this is our fabrication zone where we now build the machines. And over on the other side is where we manufacture. We manufacture more so now to prove the point that it can be done, to inspire others. And it really is more about that. It's more about the education, what can be done. So over here is our colour wall. These are all our plastic bottle tops. We receive bottle tops from our community, from schools, from people like yourselves who collect bottle tops and donate them to a coordinator. Those bottle tops are colour sorted, they are then washed, and they're polymer sorted. You'll see we've got visual cues here. We've got our HDPE in the pink and LDPE in the blue. Those are the plastics that we process here. They're polyethylene. And the idea is there that we can melt plastic in an environment like this without having to worry about fumes or anything like that. The visual controls lends itself to lean manufacturing, which I know is something you're interested in. The idea is that it's simple. We want to make it easy for our workers and for us to understand what we have on the shelf without having to sort of go up and read a label or scan a barcode. We can quickly look up at the wall and say, we've got half a tub of green HDPE and so on. So the idea here is I'm implementing a lean process. Are you guys interested in lean and sort of learning a little bit more about that?
Yep.
Yeah. Okay. So with lean, so it's something new for us as well, where it's going to be a bit of a journey that we're on. The idea for us is not to go traditional. It's simply to fix what bugs us. So every day the team comes in, first 15 minutes of the day, we tidy up. We do this thing called 3 S's. It's traditionally 5 S's, but we sweep, sort, and we standardise. The idea is we clean our workspace, we put our tools back on the wall, and we fix something that is bugging us. So for example, I keep walking into these 2 PowerPoints. The next time I fix something, I'm going to be tying them up to the wall a little bit so I can stop hitting my head. It's to fix what bugs us. There are waste components of lean. If you turn around, there's actually the picture on the wall. Trudy, could you read out those? Just read about it. I'll tell everybody what they are. Just can't see.
So the 8 wastes of lean are defects, overproduction, waiting, unused talent, transportation, inventory, motion, and extra processing.
Excellent, thank you. So when we look at lean and in our 3Sing, we're looking to eliminate those wastes. The idea is, if we're producing something in a batch, let's say we're producing 500 or something, and there are 3 steps to it. We produce 500 and then we get to the next step and we realize that there's defects. We have to fix up all of those defects, we have to do it again. It's wastage. Now, if we had a 3-step process and we produced one of those products over on one of our machines, we passed it over to the next person who's doing the hand finishing and realizes that there's a defect, it can be fixed straight away before we get 500 and have to fix them all. In that case, we don't have wasted motion by putting it back and forth different areas. We don't need to store it on our shelves and have to work it out later. And that goes to overproducing as well. We don't have things on the shelves just waiting to be sold. Everything's built to order as required so that we can invest our efforts into what's actually going to pay the bills. So we'll walk through a little bit further and we're going to get into sort of our products and how we sort of develop and update our products. Our main product is probably our machines, cassette products. So our machines, again, were inspired by precious plastic, and we went to redevelop for schools and community groups. We were listening to schools, what do you want, what's safe to use, and we decided originally that we were going to do a small, bit safer shredder. The idea was that it was going to be hand cranked because it's engaging, and we felt that it was safe and easy to use. But what we realised very quickly was it was actually pretty tiring to use. So from that we moved to a few other different versions, and we've got the final version over there, which I'll get you guys to have a look at and play with later on. The idea is with a shredder, your material needs to be shredded down to a small granule before melting. If you just throw a bottle top in, it's going to take a lot longer to melt, and it may not fit into the hoppers. So the idea is to start with a prototype, test the theory, get feedback, and then rewrite our next version of the design. Another example of that is our benchtop extruder. Again, we've got the final version over here. This dusty old machine was our first benchtop extruder. Came out with me to lots of events and workshops. It's still going, which is great, but what it taught us was about safety, having heating elements exposed. At the end where we're sort of demonstrating was a bit of a challenge, especially because people like to touch hot things, just like they like to touch wet paint. So the idea was to enclose it all, but sort of keep it all visual, because I think people are pretty interested in how they work. Again, I'll show you what that is over here. Come through here. Now, actually, if you turn around behind you, that is our extrusion machine. So that's a machine we built here as well. That extruder will extrude or mould a profile, like a beam or a plank or a brick. Because, Trudy, have you got anything there? Yeah, good. Okay. All right. So those, we actually make our plant stakes. We've got garden stakes. I'll see if I can find one. It's actually right behind you here. These are probably our defects. Okay, so we need to rework these or granulate them. These garden stakes are produced for a local company. We're producing at 2,000 of these at the moment. And the idea is that it's a high value garden stake. It's not something you find at Bunnings, 3 for $10. It's 1 for $40. And by having an expensive product like that, it allows us to be paid, allows our customers to be paid, and someone has a really nice product. The idea is if everything's cheap, people will devalue the work that goes into what we do. Everything we do is, everything we do is it's essentially manual, and we've got to pay our staff with the lights on, so it's slow. So we need to focus on high value products when it comes to manufacturing. So another example, I'll pass them around. Another garden stake that we do for another company. And we actually used that machine to produce this plant pot. The way we did it was we put plastic into the end of the barrel, into the hopper. We turn the motor on. The idea with the motor, it spins a screw, and as that screw is spinning, plastic feeds through the hot area and out like a hot noodle or like hot toothpaste. We're then able to capture that hot toothpaste into a mold, and once we hit the line, we moved that mold over to our press and we squashed it. And then we came up with quite a nice and unique pot plant or pot. Generally, when you think of pots, you see blank colours, black, blue, grey, or whatever it is. This is something unique that we're able to develop and have a market for. All right, so we'll walk through this way, and we're actually going to be walking into our sheet press production line. This is a new product that we started building. So a sheet press, the idea behind a sheet press is to produce a large panel. So you can see the panels are here in the middle. This machine, the design of this machine, again, were given away free on the Precious Plastic website. Our designer likes to push the envelope, as we do, and pioneer. So we actually redesigned it. Interestingly, I said to our designer and our builder, how long will it take? And he goes, I think we should be able to knock it out in a month. 12 months later, we've got out the final product, so it takes a lot longer sometimes. And what you need is foresight. You need to understand what barriers and challenges you're going to be faced with, especially with innovation. You test something, it doesn't work, you try it again. Everything here is locally produced, obviously, which is very expensive. Also, this machine, we thought in parts were going to be about $5,000. I think in parts we looked at about $15,000, and in labour, we're probably looking at 6 to 12 months in labour. So it's a very expensive production line. The idea is and how it works, we've got our galvanised sheets, we've got a mould, which looks like this. We pour our plastic. So the idea is you can pick the plastic you need as your pallet, you pour it in, put another sheet on top, and you squash it. You squash it under pressure, so it's about between 5 and 20 tonnes of pressure at about 200 degrees Celsius. That will melt in there for about half an hour. It then comes out and goes into this machine, which cools the product, and then you can take it out. And what you get at the end of it is a unique plastic sheet. This is 32 kilos of plastic. I won't pass it around, but I'll get you to come and have a look at it. I'll just pass it over here, and then you can have a feel. And interestingly, that's not what I was expecting it to turn out like. I just threw plastic in and it came out quite beautiful. On its own, it's almost like an artwork. If you look, So different colours will provide different variations, different pressures. If you mound the plastic here, it might spread that way. It's still something we're working on. These are just the tests at this stage. The material will be used for things like shop fit outs. It can be used for tabletops, chairs. We did a store fit out for Converse a couple of years ago now. We, with our smaller sheet press, we made all of the shoe racks, a couple of tables, the bench tops. It's just a new material. Now, when we value it, it's a little bit tricky, because when we think of surfaces like this, we might compare it to, say, plywood. Plywood's not very expensive. You might be able to get a sheet like this for $150, $200. Whereas we need to consider the labour and the footprint and what we're doing when we value these products. So something like this, probably at the very base, would be $500, and it's going to go up based on material. So our material, there's some supply and demand here. Now, in terms of our supply, they're bottle tops. We've probably all got a full cream milk bottle in our fridge. If not, we might have a light milk bottle, or we might have a Tetra Pak. So there's a few colours that have, let's say, dark blue, light blue, white bottle tops. And then there's everything else. If you just turn around again, you'll see all the variations in the colours. You'll see that we have maybe less cream. See the cream in front of you on that third row? Vanilla Coke bottles. No one drinks vanilla Coke, obviously. Whereas there's lots of red. There's juices. There are flavoured milk lids. What it means though is there is a value. Okay, so where we've got high supply, it's a cheaper value because we sort of need to get rid of it, but also there's a lot of it. Where there's less supply, it's a higher value because it's a little rarer. For example, if someone wants a cream, they're going to clean this out, so the price is higher. So that sort of dictates what the prices are for these sheets. So yes, so coming through now. I've answered some design questions. If you have any design questions that I'm going to answer, yeah.
How much do you give for your product when you sell this?
It's interesting. So we don't normally we don't normally sell our product. I guess our market is not selling our own products. It's providing solutions for other people. What we do, and this is an illustration and a demonstration of what can be done. The idea is to then get other customers in. So two parts to that. One, from a brand's perspective, let's push the envelope from a brand's perspective. Let's not be boring. Let's do something different, but also let's reduce waste. Now that's pulling 30 kilos out of landfill. That's important. If we were able to fit a whole shop out, that could be a ton of plastic that didn't go to landfill. It's an important part of the story. We've got our own products. We sell because some people do want to support what we're doing. We've even sold a small little caravan that went all the way over to Norway, just because people wanted to support what we're doing. But to answer your question, it's probably for the machines. That's probably our highest market. We've got probably 80 or so schools, something like that, that we now have our machines. All right, come through. So over here, this is what we've got in terms of our workshop today. So you saw the machines earlier. This is the commercial variation of our bench top extruder. So the little machine that I had over there, and our plastic shredder. So again, they're redesigned to be safe, but also to look nice. We can't put something ugly in a workplace or in a school. The idea is though, this is clear so we can see what's happening. I think everyone's interested in watching things get crushed up and stuff like that. So we kept it clear for that reason. I'll quickly turn them on and do a bit of a demo. So the way this works, we've got blades in here that rotate. They go forward and backwards based on what you set, and we've got a speed control. The idea is that we need to crush our plastic to produce the raw material. Popping lids, so one by one, maybe having 3 or 4 in there at a time. The idea is that they bounce around and they knock each other around and they're able to be crushed up. Down the bottom here you'll see the small flake that we're producing. And then from that small flake, we put it into our bench top extruder. The bench top extruder works in a very similar way to our large extruder that is a motor. Except it's got a handle. You guys are the motors. The way we can explain, sorry, let's see raw plastic goes into the hopper. We crank the handle, and out the other end comes a little piece of molten plastic. In this case, it's just a little bit hard, but the idea is it comes out and into a closed mold. So so we can produce a product over and over and over. Thank you. Recently we had Ivanhoe grab and drop off large tubs of their 3D printing waste. If you guys got 3D printers at school, you might have produced waste yourselves, being that it's the rafts or the supports, might be the end of the spools. Generally, that plastic's not recycled. If you've seen a number 7 on the back of the recycling packets, it means it's just a category basically. Number 7 means all other plastics that are not recyclable. Unfortunately though, it is recyclable, no one's doing it. So we were able to shred the plastic for Ivanhoe. They've got their set of machines and now they're going to be producing new products for themselves. The idea is it's a circular economy. So they're able to use their waste and turn it into something new. Another example of a circular economy, we work with a company called the Dirt Company, who sell laundry detergent by way of mail subscription in these bags here. These bags are a low density polyethylene, like any other plastic bag, but also similar to the low density polyethylene we have up here. The difference is this is film grade and that's injection mold grade. So this company, they will sell their customer a bottle of laundry detergent along with a refill sachet. And when that bottle empties, they'll send, I guess they place their order for their next refills. Refills come, they fill up the bottle, they send these back to the company. And they might build up a few and then send them all back. Now, when this gets back to the company, they'll put a little sticker on there saying 1, 2, 3, 4, 5, 6. It'll be used 6 times and then it needs to go into retirement because what happens on the 7th is it's probably going to explode or it gets weaker. They have a problem with their waste in that case. They came to us and they said, look, can you recycle our plastic and can you turn it into our new product? And that's something that we strive to do, provide solutions like that, because generally nothing else will happen. Unless someone like ourselves will get involved, nothing happens with plastic like this, it just goes to landfill. You can't do anything with it. So we worked with them, we started receiving their pouches, and we shredded it down in our shredder. Come through here, you can see our shredder. This is our commercial shredder. It's a small, old machine. It was built in Japan in the 80s, and it's still going, which is amazing. Things don't usually last as long, especially when they're breaking things. We pop it in our shredder, and we granule it into a fine flake, which looks like that. It's pretty light and fluffy. And then from there, we're able to produce part of their next product, which was their scoop for their laundry powder. It's a circular economy. We're using their waste to make something else. And that then can be recycled again and again if it comes back to us. We sold them the machines, so now they can take that waste themselves and turn it back into another product. The idea is using what we have. Although it is probably more expensive to do this, there's plenty of waste out there. It's a valuable resource. As you can see here, this is a valuable resource for us, the bottle tops, which is something we'd normally just throw out. We wouldn't think too much about it. So there's sort of two types of clients we work with. One with a pretty a standard idea. Can you make me a product? To start with that process, we go through design. So we have an industrial designer who designs a product for them. And let's say we're talking about a scoop. We ask our clients to provide some reference. What do you like? What have you seen out there as a starting point? Or give us a sketch. Our industrial designer will then turn that into a CAD design, computer-aided design. We then put that through to an approval process. Once our client ticks off on that, we go to design the mold. Now the mold is the negative of the product, and that's probably the trickier part because you've got to think of things in backwards. And then from there it goes to tool out. When we think mold design, it's not just about the opposite of the product, but can it be machined by a CNC tool maker? So truly we've got some examples of molds. This is probably the original one we had for the Dirt Company. I'll pass around these to you guys. I'll pass it around. These are aluminium molds. They're CNC machined with a CNC router. It's a 5-axis router, so the idea is that the aluminium moves and a little router bit will then, I suppose, machine out the material, take things away. When we're designing it, we need to make sure that our toolmaker can actually cut it. If our toolmaker can't cut it, we need to make changes to the designs. Now, an example of what our toolmaker can't do: sharp corners. He can't do things upside down and backwards. So that's always something we need to think about. The second thing we think about from a mold design perspective is, can we take the part out of the mold? or where are the part lines? So for example, if I show you one of the scoops, I'll pass around some of the scoops. If you pass those around, you'll see we've got text. You'll see that in the ones that are joined together, you'll see we need to think about which way the plastic flows. How does it fill the mold up? Can it fill up the whole mold before it cools down? We need to think about the amount of pressure we're able to put into it, how thin the walls are. And I guess the other thing is how many of these products can we make per shot or per time. So that's an important factor. This particular machine was produced on our injection molding machine here. This machine was purchased a couple of years ago now. It was previously making parts for Holden up until 2017. It was making a very small part, which I found on the other edge. This big machine was making this small part for this machine, for Holden. It's a little brake part, and that's all it did. And it's probably a 60, 70-year-old machine. It's been in Australia for quite a while. I suppose it was built in the States, but yeah, it just produces a little part. When we bought it, we thought, wow, this thing's going to be amazing. We'll be able to produce such high volume stuff, but yeah, just does little stuff, unfortunately. The second style of client or product design phase we need to go through is testing material. Now, just like our customers here, they wanted us to test their material. Can it be recycled, and then can it be recycled into the type of product we want it to be in the end to sell to our customers. So we've worked with we've worked with universities testing new materials, so whether it be bioplastics or common plastics. We're working with one at the moment who is they've got a dispenser for liquids, and inside the dispensers they've got plastic parts that they want to recycle. So we're looking at how do we work with that material in our machines, and then what product can it turn into. So all plastic's different. Now I'm sure everyone's seen a little recycling symbol on the back of a plastic object. So we've got 1 up to 7. One is PET, so commonly a Coke bottle or a water bottle. Number 2 is high density polyethylene. Number 3 is testing me. I'm going to say it's come back to it. Number 4 is low density polyethylene. Number 5 is polypropylene. Number 6 is polystyrene. I'm guessing that number 3 might be PVC. Not all plastic is recycled in the curbside. So just because it's got one of those symbols in the back doesn't mean anyone's going to do something with it. There are only some plastics that are focused on. Now, so polyethylene, high density polyethylene or low density, pretty common here in Australia, as is PET, so number 1. But no one's really recycling PVC, or no one's recycling PLA, for example. A couple of reasons: it's tricky, it's low volume, or there are fumes to consider. So even if you're melting polystyrene, so polystyrene comes in a few different styles. Think expanded foam, think CD cases. You guys have seen CDs before? I know you're young, but I'm sure you've seen CDs. Polystyrene, bread tags from bread bags, polystyrene. If we were to work with polystyrene here, we'd be wearing hazmat gear almost, face masks, but we can only work with it for 8 hours a week, even in those conditions, because it is toxic. Polyethylene is fine to melt in an area like this. We don't need ventilation. We do crank the door on occasion, but it's generally fine to melt. So therefore, there are different plastics with different properties and different values. They melt differently, they flow differently. So yes, so going back to it, we do test materials for our customers to then prepare a mold for production. So what we'll do is I'll show you how we're going to use that machine, the vegetable extruder. We're actually going to make pens today. So we've got a new mold. You guys will be the first to receive a pen. The idea is for us, produce something tangible, right? Something you're using. You're all using pens today, right? So rather than giving you a key ring that we're just going to pop on our keys and we'll forget about it, we'll get something we can hold every day and probably look after. I've lost millions of pens, I'm sure, in my lifetime. Hopefully you don't lose these pens because they're your own. You didn't make them yourself, and hopefully have a high value for you. So this is like a big paint pot, essentially. We choose our plastic colours and what we get is what comes out, essentially. Now, if we mix blue and green, no, blue and yellow, we do green. Purple and blue, we get, purple and red and purple, red and blue, we get purple. Number 2 is the yellow. But if we start mixing other colours, we might get browns and greens. What I did the other day, I actually did a workshop for a company, and I took out a bunch of clear and a little bit of like the primary colours, and we made some really amazing things. So we'll just start with the clear, and we'll get the primary colours out, so that way you guys can sort of mix it up. Now, each pen is about 6 grams of plastic, so it's not a great deal of plastic. So you might be disappointed with the results. It might not turn out green as you wanted. It might turn out the colour of the person before you were trying to make. But it's going to be unique. It's going to be your own. Okay. So I'll just show you quickly. The idea is I'll put a bit of clear in, make something we're going to use. It's something that we thought of a little while ago. Trudy and I actually went to office work, and we thought, how can we be inspired? What's out there? There's no point reinventing the wheel. It's like the second person to make a phone didn't go figure it out. They probably copied the other guy. So we went to Office Works and we went through all the pens. What are the refillable options? Unfortunately, they're just big pens that we could sort of see in the style that we wanted to make. We wanted to make something that fit this style of insert. So step one was find something like that. We didn't find it because they were all big pens. We actually found a pencil that we liked. And we sent that pencil to our industrial designer and we said, this is our sample. We then also found the pen inserts. This was a bit tricky too because I don't know what they're called, pen inserts, refill pens. It took a little while to figure them out. They are ball stick refills was what we found. So that's what those are. And then obviously we sent that to our designer. We said this is the fitting, and then you need to allow for tolerances for this type of plastic. Now this plastic shrinks, so when we design it, we need to anticipate the shrinkage, the flexibility, lots of different things. So this is iteration 1. It's already now in iteration 2 where we're getting it remade. What we found was there's a part here that's a little bit soft. We want to make it a little bit harder. Nevertheless, it's going to work perfectly fine for today. So these molds are, again, aluminium. Can I have that set? Sorry, Trudy. These are aluminium. They're milled in Geelong. So our toolmaker is in Geelong. We make these pretty easy to assemble and disassemble. I'll just show you before we get started actually. So we've got little wing nuts here just to make it easier for us to open. Now inside the pen, obviously it's hollow. That was one of the things we need to consider. You know, how do you make it hollow? Well, does anyone want to take a guess? How do you make it hollow? Okay, I'll show you. We had to make a little pin. So that makes it hollow. We need to think opposite when we're talking about molds. Now, the machinist had to mill this on his mill. It was quite tricky. This is the bit that we're changing. Because it's aluminium, it's a little bit bendy and can break easily. So if we're sending something to a school, I remember being at a school, I probably wrecked things just because it's there. You know, you guys probably would do the same, unfortunately. So we're going to try and make it stronger and durable so that if you are a bit heavy-handed, it's not going to break. Okay, so that's the mold. And I'll just show you. So the way it works, we've got our little pin that aligns, drawn a little mark on it, it aligns on this side. And then we close it up. Now we've got this is the fitting, this is what connects this mold to the machine. That goes in here. And then we close it up like that. Now, traditionally, if you think injection molding, let's say the phone cases that you've all got, that's injection molding plastic. A mold of that type might produce might produce 5 cases at a time. It would probably be valued at $100,000 to $1 million for a mold. Okay, so it's something that will produce a lot of products. It's the most expensive part of the process. These molds are not worth $1 million. These are low-cost molds, they're aluminium, so they've got a limited lifespan, probably up to between 1,000 and 5,000 pieces. These we're selling for about $1,300, so vastly different from a $100,000 mold. Okay, so the idea is with a machine like this, even though it is low pressure, you need to have a very good clamp. The clamp needs to be stronger than the pressure this produces. And if it's not, we create a defect, which is a waste. And it being a defect, it means we need to go back over it, hand finish it, or we have to granulate it and start the process again. Alright, so I'm just going to turn a little bit of this plastic through. We're going through the barrel, we're melting. And because we've let it sit for a little bit, we will have a little bit of a cold shot at the end here. So safety first. The barrel is melting this plastic at 180 degrees. Okay, so we're boiling water at 100 degrees, it's a lot hotter than that. So this end of the machine is hot. I'm wearing gloves for the hot things, and I'll focus on touching those hot things today, but just be mindful it gets hot up here. Okay, so we take that little noodle out. Now, that plastic, you can see it here, it's like hot bubble gum at the moment. As it cools down, screw the lid on. Okay, and the tiring and butt bit begins. So we crank the handle. Now, in many of our molds, we have an air vent. The idea is to let the air escape, and it lets us know when the mold is full. In this one, it's one of the other changes we need to put in. We need to put a vent in, so we need to sort of feel when it's full. You feel it, it's like an increased back pressure. It almost feels like it's getting harder and harder to produce. I can sort of feel it now. When I let go of this handle, it'll probably start spinning the other way. See that? That tells me it's full. There's nowhere else for the plastic to go. So we take the mold off. Now this mold, the first one we do is usually the sacrificial one. It's going to heat the mold up a little bit. It's not going to be as nice as the last one we do. A hot mold allows plastic to flow further. Okay, so we need to keep the plastic hot to flow before it cools down. If it cools down too quickly,
I think it's not so hot. Touch it.
Ready? Okay, that's our pen. Now, trim the end of this. It's not the nicest colour. Let's see if we can fix it up. We'll just pop in this little device here. I'll be able to get this core out. Pen insert. Now we've got a 100% recycled pen ready to use. It's something that was a waste material. It's now something of value, something we pay for and we buy. So the idea is we're all going to make our own pens. I might clear this colour out a little bit because that's probably the ugliest pen we've made. And then we'll see who wants to go first. First one to put the hand up goes first. There we go.
Gary.
I'll just clear it out. Any colour preference for you? What's your favourite colour?
Purple.
Purple?
Yeah.
Okay, we'll give it a go. Trudy, do you want to go Barden? Now, when we say purple, we can put straight purple in, or we can put a couple of different colours in, and we can come up with our own purple.
Do midnight purple. Midnight dark. Purple and dark. Yeah,
That's what the
purple and
question-
blue.
Purple and blue, alright, let's see how we go. So actually over on that wall, so yeah, if we have a look, we'll just go a little bit further, guys. To make life easier for us, we actually have our plastic material in all sorted in dispensers. This is something you normally see in a bulk food store.